Thank you. Good morning, everyone. I hope you can hear me well, and thanks very much for joining us. And as Ollie said, Arc Thermal, we are we specialize in infrared heating solutions as well. So there you go. I think you can all see that, hopefully. And what we do, so I can put this into, excuse me one second. So Arc Thermal, we have been installing infrared heating solutions for the past 10 years, and predominantly most of our businesses came from community buildings, village halls, and the likes. We are the sole distributors of a Therma products. Therma is a Austrian manufacturer. They've been manufacturing heating solutions for over 40 years, and we are the UK distributors for them, so they're well known in terms of infrared and also electric heating solutions for homes, businesses, and commercial opportunities. So today I just want to cover a little bit about community buildings and how infrared heating works in that environment. And I'll just explain a little bit about how it all works and give you an idea of systems and what it will entail. So, so first to begin with, and this is what we'll discover how infrared works, how different types, learn about the different ranges of infrared heating, understand the difference between short, medium, and long wave infrared and how it's used, answer common questions, and understand the complexities regarding the comfort and performance of infrared heating solutions. So, quite simply, we all are affected by infrared rays, and if we were in the sun, I think the temperature outside today is maybe 10 degrees, thereabouts, but the sun is shining, so it might feel like it's 15 or even 16 or 17 degrees. That's kind of what we're trying to achieve in a building. So we take that same band of rays itself, infrared rays, and electrify them, really. So it more feels like if you're standing in the sun, and although the air temperature might feel totally different. So the first thing infrared heating does is heats the fabric of the building, the people in the building, the objects in the building, and the last thing it will heat is the air, which is counterintuitive to convection heating, which most of us are accustomed to. Because with convection heating, we're trying to heat the air and hopefully circulate that hot air throughout the building and gives you that warmth that you want. With infrared heating, it's different because we're direct heating solution. So it is basically we're directing the heat where we need to go, which is in the fabric of the building, you and all the objects in the building. So you get a more even distribution of heat. And typically, the air temperature is between 2 and 3 degrees. You'd feel it a little bit different. So what tends to happen in village halls is they call me up and says the thermostat is saying it's 16 degrees, but people are feeling it's 19 degrees or feeling it much warmer. So in some cases, we tell people to turn the thermostat down to give you that effect. So infrared heating travels through electromagnetic waves, and again, it absorbs into the walls, floors, tiles, and etc. The building, as I said, and as a result, you get less cold spots and a more even and stable temperature reading. And in most cases, it's going to be using less energy, especially if you're moving from electric to infrared. It's just it's typically about, I would say, 20 to 30% in terms of the first electric. So if we're moving from a 3 kilowatt heater, we would typically move from a 3 down to maybe a 2 kilowatt or even a 1.5. Just depends on how the building is. which I'll walk you through in a minute. So again, what we're trying to achieve is an even distribution of heat across all surfaces, all room types. And the heaters can be mounted on walls and on ceilings as we go through. So these are the different types of infrared waves. You might be accustomed to seeing shortwave infrared. I think Ollie and I were discussing shortwave infrared a moment ago, where you have the red light and you have this beam of light coming to you. And if you go to a pub, sometimes you press an outdoor button and you get this red mist come on to you. That basically is shortwave infrared. It's very good at heating that narrow space in front of you. So maybe a meter, meter and a half, maybe 2 meters for the most. As soon as you step out of that band, you get limited or no heating at all. And then you have medium wave infrared, which is what we would typically use in village halls, churches, warehouses, and large buildings. These heaters, as the name suggests, it travels the heat further than shortwave, and also it has a combination of long wave and shortwave. So what you do get is higher surface temperatures. So a typical medium wave infrared heater would have a surface temperature about 270 to 280 degrees Celsius, which means it has to be installed over 3 meter heights. And it is not safe to install below 3 meters in most cases. And the reason for that is you get a higher concentration of heat at the heated level, but it also projects the heat down as a cone of heat. So what you will see in a few slides to come, you will see heat dissipating from the heater, almost like if you turn on a light switch, you know, the old fluorescent fittings, you'll have a light beam going that way and a light beam going this way. That's a similar situation with the medium wave infrared. Other areas where we use these are like in aircraft hangars and very large areas. And the last form of infrared is long wave infrared. Typically, these are used in domestic applications and offices or ceiling heights that are below 3 meters. So if you have a suspended ceiling, for example, and the ceiling height is 2.5 or 2.6, we would put the heaters in the suspended ceiling where you can't actually see the heater at all. All you know is just you remove a suspended ceiling tile and you put a heater in if you have that application. And those are the three waves there. Is there any questions so far? Anything else? 1 second. Just pull this up.
I'll
No,
just
no.
ask Damien. Something which occurred to me: if you had, say, you had a hall with a very high ceiling,
Yeah.
how would you decide between kind of medium, like a medium wave heater at a lower height,
hmm
or a long wave heater at a higher height? Does that make sense?
Yeah, yeah,
Okay.
yeah. That's so. Well, what before we get into the specing of the heater, we have to go through a fact-finding mission first, and the fact-finding mission would entail when the building was built, the type of U values of that building, what are the walls made of. So we go through that full process before we assess which heater is right for that application. And after that, then it will tell us, after we've done our heat losses and our understanding of the building itself, it will tell us what watts per square meter we need. So we'll work backwards based on the building type, based on the environment, based on we would say, okay, we need 150 watts per square meter, argument's sake. And then we will then say which heater in which environment gives us that watts per square meter with the most efficiency. So we work backwards, and that might entail that we go with the long wave infrared, for example, because the ceiling height might be in different areas. So I've done a hall in Oxford where they had long wave infrared, and this is just an example. They had long wave infrared heaters installed at 3.5 meters, and They installed this because the local builder, the local electrician, sorry, told them they had these would work. He went to a wholesaler and says, "This is the square meterage we're working with. Give me something to work." And then work back and it says, "Okay, based on the square meterage, you would need 10 heaters." So they installed 10 heaters. No idea of the building type or anything like that. They just bought heaters and installed it. And the customer came to us and says, "It's the hall, and it's a fairly new hall. And the hall is never, never, never warm." I said, "Well, when I went to the hall, I said, well, it's never going to be warm because you have the wrong type of heaters installed." So long and short story is that we got the right heater in place, and we managed to repurpose the existing heaters that they had into different rooms, and the customer is happy. So that just tells you about, yes, question. I think Perry has a question. Patty, sorry.
Morning, Damian.
Morning. Hey, how
you?
you doing, sir? How are you
Uh,
doing?
I'm doing very well. I thought you were actually just going to carry on there. I was going to just ask a question about the temperature in the hall after we fire up the heaters.
Yes.
I'm glad you went through the part about you're heating up the air, and so therefore the air is going to be the last thing that heats up in the hall. But an issue that
Yes.
perhaps we're encountering is when you've set the temperature remotely and you're monitoring the temperature remotely and you have a hire going on, and let's, for example, say it's during the winter where it's cold, it's very difficult then, if the air is the last thing to heat up, for us to gauge whether the hall is hot enough or warm enough for the participants in any event that's in the hall. Because we've got an outside temperature, you're monitoring remotely what the temperature is in the hall, and because you're remote, you don't actually know if it's comfortable in the hall for the people you've hired it out to.
Yeah. I know exactly what you're talking about. And what tends to happen is we calls in the past, what they do is they ask the question to the existing halls, and they get their feedback, and sometimes your feedback might be it's too cold or it's too warm, and then you adjust it accordingly. Um, and that's what we've had in the past, where in some cases we've had to drop temperature because of the U values. Drop the temperature by 2 or 3 degrees, and in some cases we had to increase it by 2 or 3 degrees. And I know your cases, we have a special case with yourself, so we need to make sure that things go well with you. By the way, have you put the lock on the on? Sorry, have you put the lock on?
I have. I switched it with the one from the. I switched the casing with the one from the bar, so it's fully locked in. So we haven't had any other incidents up till now.
Okay, great.
And yesterday when I checked it, the lock was still there.
Fantastic. All right. So this is one of our customers. This is Orford Village Hall, and so just a bit. I have a little more to go through. I'll take one more. Martin, okay. I'll take that before I continue on. Martin, go ahead.
Yes, thank you. Currently, we use conventional oil-fired boiler and convection heating.
Yep.
But with a smart controller, we time that to coincide with events. Can we have the same facility with an infrared solution where either we can control power or control time around the events?
So yes, yes, and yes. Yes, and maybe, let's put it that way. So presently we have a calendar, not a calendar booking system, a 7-day app-based system where, as Patrick would do, would put in his events happening at whatever time of day, and the heating would come on to allow that. We are working behind the scenes, and this is probably be news to you, Patrick, as well. We're working behind the scenes with Hallmaster and different companies to have integration with a calendar booking system. meaning it would be if you have an event happening at the 3rd of June or the 5th of November, whatever, we can schedule that to come on before time for that particular booking. At the moment, the app only allows you to do 7 days. So if you have an ad hoc booking at 2 weeks' time, you will have to go in and that time and put that in. So we are working on that.
Is it just day, or are there on-off slots through the day?
You can put multiple events. So you can have, if you have a booking in the morning, you have a booking in the evening, you have or the afternoon, you're booking in the night. You can put multiple bookings. However, you will need to put, if you have a booking, to tell it to come on, you have to tell it to go off. So you do have to do those things. Patrick.
Yeah, just one thing there. When you said that you're working with Hallmaster,
Yeah.
and I think that's fantastic that we can actually build that in, so we can then program the heating to come on beforehand. But
Yeah.
for that to work efficiently, we would need guidance as to what period would be recommended for coming on prior to that event happening, to make sure the facility is up to heat for those people coming. And just to
absolutely,
go back to what Martin was saying just now, yeah, I think that there's a limit of, I think it's 64 events in that
that's correct.
7-day period, and therefore, if you have a number of events and you are booking them on and off and on and off, sometimes you can actually eat up your 64 events within that week. So that you have to then start allocating or putting together some of the events so that you can actually program for the whole week.
So yeah, that's true. What I said, we're working behind the scenes. We're not only working with Hallmaster, we're working with Delta Door, the manufacturer, and any booking system really. So we'll be agnostic on any booking system that you have. We'll be able to plug into them via an API and run our platform on the background, and that will take into account external air temperature, and it will then learn how many minutes, how many hours, how long it would take for us to get from one temperature to the next. But I'm not doing the coding. I'm just reporting what we're doing. So, and hopefully that will work, and we'll have a launch of that later this year, hopefully, knock on wood. So, okay, I'm just going to continue a little bit. And can you still see my slides?
We can, yeah.
Okay, brilliant. Okay, I'm just going to go back. So, permit me. So here are a few halls that have.
They have. Sorry, Damien. Your slides have disappeared now.
Oh, has it? Okay, sorry. Escape. Okay.
Your camera seems to have switched to you, Damien.
Hey, sorry guys. Okay. Is that better?
Yep, that's back now.
Okay. Let's go back through all that. See that one? Okay. So different halls. This hall at the bottom is Kim Bolton Village Hall in Kim Bolton. This one is Berrien Arbor Village Hall. And this is in Oxford. This is Alice Marshall Village Hall. 3 different types of village halls. One that is Alice Marshall is pretty well insulated, one that isn't well insulated, and one that's moderately insulated. Again, it's designed for large spaces, high ceilings, intermittent use, frequent opening of doors, and you get the zonal heating as needed. Total cost of ownership. So one one element that we have here is there's nothing to maintain. There's no moving parts with infrared heating solutions, which means there's nothing to go around. So typically what we would normally have is either the electrician has done something on the installation side that wasn't correct, but the physical product itself, there's no moving parts to it. Lifespan, I'll give you an idea. I replaced a set of heaters that was installed 23 years ago at Salisbury Cathedral, one of the buildings in Salisbury Cathedral. And the reason we replaced them is because they were installed incorrectly. They were installed, this is the medium wave infrared. They were installed at 7 meters high, but they went straight onto the plasterboard ceiling. So over the years, what happened, there was no gap between the heater and the plasterboard. So over the years, heat built up behind the heater and then burnt out the connections to that heater. And that was the only reason we had to replace those heaters. We've since replaced those heaters to the same heaters that was there previously, and suspended them to, I think, 6 meters, and it's working perfectly for them now. Here's a typical example of how we would do zonal heating. This hall is in Norfolk, and what we've done six. In the main hall area, can you see 2 thermostats? So 2 T's, one there and one there. The customer wanted 2 zones, so that if they're using just the front of the hall for meetings or whatever, they can have the heaters on there. And if they're using the whole hall, they can turn the two zones on, giving you an even distribution of heat throughout the zones. So just as an example, we have 10 heaters divided. What is the? I'm just going to give you a quick example of. Bear with me 1 second. 1, 2 plus. So in the main hall area, we've gone with 140 watts per square meter in this hall. That's around typically what we would be looking for depending on the insulation properties of that hall. So this particular main hall here, there's no external walls. As you can see, everything has a wall all the way around. There's no windows. So this is within the parameters of a moderately insulated building. Other rooms we have zoned. So small hall is 95 square meters divided by 8 by 1600 heaters, and because each one of those areas is controllable via the app, and also controllable locally as well if you wanted to. So this is our journey. This is our product journey. So we start with the inquiry. We gather the information, which would include, let's say, a floor plan, some information about the distribution board, existing pictures of heating. We design a desktop proposal at that stage, and if the customer is happy with that desktop proposal and wants to take it further, because what typically happens with village halls, and I'm sure you guys are aware, you need to get your funding in place. So sometimes you come to us just for a proposal to go for funding, and when that happens, then you say it might take 6 months, it might take a year, depending on how the funding situation is. And you come back to us and say, well, okay, we like this, we wanna take this forward. Then we arrange for an installer to come out and together with myself most of the time. We come out and we look at what we've assumed, and if there is any adjustments that was needed, we then tell you at that stage. And if you intend to proceed, then we go ahead and we do the proposal, and we arrange for an installation date with the final proposal intact. Final proposal signs off, 50% deposit and 50% on completion. And we arrange for the installation date. We then get completion certificate, handover documents, and final payment. And we do customer follow-up as well. So if, right, any questions on that? No. Okay, fine. I will continue again.
Yeah, I've got a question.
Sure, go ahead.
Bill Watts, yeah. A typical way would be to get 2 or 3 estimates from 2 or 3 different firms. So how does this work with your plan? You get as far as the first proposal, and then the committee will have 2 or 3 different proposals, and they'll then decide which one they want. Is that
potentially? Yeah.
Yeah. And there are no costs to getting the proposals.
No cost to getting the proposal inside. No.
Okay, thank you.
That's fine. So we've
Damian.
had in the past, we've had customers come to us for more than one proposal because it's a struggle to find the products that they want, and we've been able to give them an additional proposal. Now that's off the record, but we're able to provide an additional proposal if needed. But yeah, we can do that. Patrick? Yes, Patrick, I can't hear you. So you're still on mute, Patrick. So I can't hear you. You're on mute.
Can you hear me now?
I can hear you now.
Right. It's not just because Damian is sitting here, but as somebody who's been through the process, and when we got our quotation in, it was good to see that it was quite transparent how all the costs were broken down. So we had complete visibility as to various elements of what we were actually looking at. So cost-wise or transparency-wise, the process was good for as far as we were concerned.
Thank you very much for that. Martin?
Yes, do you ever have examples of a hybrid solution of mixed wavelength solutions for various shaped halls? Some shortwave and some long wave, maybe?
We have done that in the past, but it really depends on the hall itself and how that hall wants to be used. Do you have different rooms that you're thinking of, or you're thinking of the same room to put the mixture of the two technologies together?
A bit like your photo that I can see at the moment. We've got a hipped type, quite a high ceiling, but with a lower hip.
Yeah.
I was wondering whether, for the more instant effect, a shortwave radiator on the hip would complement that of a long wave radiator somewhere higher up.
Typically, we wouldn't use shortwave in most large buildings, and the reason being they're really designed to heat just in front of you in just that area. If there's a large ceiling area, we would or high ceiling area, we typically go with the medium wave infrared and push that down. And they will go from either 800 watts all the way up to 3.6 kilowatts. And on the lower ceiling roofs, we will put a mixture of the long wave infrared in those areas. But I have examples of we've done that in the past.
Yeah, our hall's only 5 meters. It's a small hall, and the main hall is only about 5 meters wide.
Okay, so that would be a typical medium wave infrared in most cases.
Okay, thank you.
No problem. Can anybody still see the slides?
We can, yeah.
Okay.
Damian, can I interrupt a second?
Sure.
Referring back to the comment you made about, I think it was a church or cathedral building that had the panels placed after about 20 years. This is all new territory to me, so I'm trying to get my head around how IR actually works. Earlier on, you said that it doesn't actually heat the air, but the electromagnetic radiation heats materials that it impacts, and that warms up the air, which makes you feel comfortable. So do the panels themselves get hot, as it were?
Absolutely. So the medium wave infrared heater would get up to about 280 degrees Celsius. So you're boiling water at 100, so it gets twice, almost 3 times that. So it is quite warm. But those heaters are designed to be installed above 3 meters plus.
And they need to be installed in a manner that it does not present a fire risk to the ceiling, for example, the plasterboard.
So the reason the Salisbury Cathedral had an issue is because the heater itself was straight onto the plasterboard. So the back of the heater was bolted straight onto the plasterboard. Bottom of the heater had where most of the heat would go was projected down. So over 20-something years, what happened is the plasterboard behind the heater didn't burn, it scored, it disintegrated, and over time, the connections, because the heat built up on the connection itself, burned out the connections to the heater. And that's how come that heater was no longer working. What should have happened, how they should have installed it, there was a gap between a 250 mil gap between the plasterboard and the heater itself, at the back of the heater, and that would allow for even distribution of airflow behind the heater itself. And the heat buildup, the temperature difference between the front of the heater to the back of the heater, 1%. So 99% of the heat is projected down. Only a 1% or so of the heat to the back of the heater you would actually feel. So in most cases where I've demonstrated this in the past, where I've turned on a medium wave infrared heater and it's 280 degrees to the back, but I put my hand to the front, sorry, and I put my hand to the back of the heater, and I could leave my hand there comfortably. And I think Patrick has had that because Patrick has a long wave infrared in his hall, and the heat difference to the back is negligible versus the heat to the front. Does that help?
Yeah, thanks. On the same subject, though, related to some extent, is the infrared radiation, presumably it doesn't damage soft tissues like human beings?
No, it's actually used for therapy in some cases. So I have a customer that bought an infrared heating panel just because they had a problem with their shoulder. And they put the heater on the wall, and when they have any pains on their shoulder, they just go and sit next to the heater and feel much warmer or better, because it circulates that blood flow as well to that area, and the customer is happy. And infrared heating technology has been used, or infrared therapy has been used for years.
Do the old electric bar heaters, work on infrared?
It depends on the element itself. Some of them would be halogen, and some of them might be infrared tubes. But typically those are between 20 and 30 years old, and they're really good at heating 5 inches feet in front of you, but not really good for heating a space. That's why we wouldn't install those types of heaters now.
Can I ask one quick question?
Sure.
In your plan, there were lots of rooms unheated. Like there was a library, I noticed, and a youth room. So do they have alternative heating in there?
So that building is a joint building. So the library is a different organization altogether. So
Okay.
the library was owned by, I think, by the local council, and the village hall is owned by the village hall itself. So that's why that was not heated.
But rooms
But
like the toilet, would you have a small one or something?
You can have a small one
Okay.
in the toilets. Yeah. So we typically we would use maybe a 325 in the toilet, 300 watts heater in the toilet, and most likely put that on the ceiling. But I'll show you some of those as we go along.
Thank you.
Okay. Still see my slides, yeah?
Yeah, still got them.
Okay, good. Okay, so you can see this hall is. Can anybody see the heater in here? Anybody see where the heaters are?
Yeah.
Yeah, you can, because you have them.
No, because ours are not integrated into the wall. The only reason I know where they are is because one of the yoga studios I go to have got them like that.
Right. Okay. There you go. So this is a hall in Staffordshire, and this is a typical 2.5, 2.3 meter ceiling height hall where you have one heater, 2, 3 heaters. So in this room, we have 9 heaters heating this room. And you can't really see the heaters. Previously, what they had was wall-mounted convection heaters. Can you see the plugs on the side? And we've reduced the initial costs here. They were at, I think it was 6 kilowatts they had of installed heat previously, and we've reduced that down to 2 kilowatts of installed heat. And customers happy. This is, I think Martin was asking about a mixture of different heaters and different applications. So here we have a medium wave infrared heater over the door, and we have long wave infrared. This is in the same room. So if you enter this building, you'll enter through here, and you would look at the door directly opposite you, which would be this doors here, and you would see these heaters on the ceiling. So here is a combination. And the reason for this is this ceiling height is 2.5, 2.6, but it goes up. If you look, you'd see a bit of slats going up here. It goes up to about 6 meters in this area. So hence we put one of the medium wave infrared and the long wave infrared in this application. The heater, the medium wave infrared heater, is sitting at 3.3 meters above head height. And again, this is Alice Marshall Village Hall. They had the convection heaters. They didn't remove this one. No, they wanted to keep them in place, but they're not actually working. They're just there as dummies. And when they go back to redecorate, they will take them down. So we've got 1, 2, 3 heaters, 6 heaters in total in this hall. They have a stage, and the comments from this was installed in, I think it was in October. The comments that they've received after the installation, because they were very skeptical, as you can see by their notes. But the comments afterwards, they said the hall has never been as warm as this, and never been as comfortable as this. So they're really happy. Here's our lockbox that Patrick and I had played around with. This is not from Patrick's hall, but it's a lockbox that Patrick knows well. And this is heaters in a kitchen. I can't remember the name of this hall off the top of my head. And here is a church that we've done. This is a grade 1 listed building, and we had to get permission from, I think it was English Heritage, or I can't remember the organization we needed to get permission from, but we needed to get permission. And we had mounted the heaters at 7 meters in the air at the moment. What we had to do was go all the way up to 15 meters to drop the suspended cables down and bolt them to 7 meters. So you can see heaters on the walls and heaters down the middle. This was a very tricky installation, but the customer is absolutely over the moon. And this is this particular project is in the Forest of Dean, and it's via council. And they have since come back to us and install 4 other rooms, and they constantly coming back to us with orders every other month, which is nice to have. Kim Bolton, you got the heaters in the main hall, and then you got the long wave infrared in the auxiliary room. What happened here is the auxiliary room was an extension that was built by a local builder, and what he did not do was put any insulation in the ceiling itself. So although we have 2 heaters in here, they came back and asked us to put in another one, and we couldn't work out why, because it was built to modern standards, and it should have had insulation in the ceiling. But on the investigation, the builder did not put the insulation in, and it wasn't built to standard, so we had to go back and put another heater in. And we have heaters of different color. So this is a church in Buckinghamshire, and previously they had heaters on the lower. They had shortwave infrared heaters on the walls, and we replaced them with, because we replaced them with medium wave infrared heaters. Again, we had to go and get planning permission and the diocese approval for this church, and the diocese has come back and said it's the best thing they've done for that church. So conclusion and misconceptions. So infrared heater, if you're going for, it's not like another heater because we're not using convection. It blows hot air. It doesn't. It heats the room via heating the objects, and yeah, it doesn't harm with outdoor heating. So I'm not going to go through too much of that. And any more questions? I know I haven't taken any more.
We have just had one come in the chat from Nick.
Yeah.
I'll read this out, Nick, but if there's anything you'd like to add, obviously just jump in. So they have an old mid-19th century hall, no cavities, kind of solid brick walls. It says the hall is used a few times a week. Condensation is a problem. Since the IR heaters don't heat the air or circulate the air, would this make condensation problems worse?
No, it'll actually make condensation problems better. It will dry out the room. The reason being, you'll be heating once the stone, the reason you have condensation is what tends to happen is you have moisture. And if we suck some of that moisture out, which is what infrared will do, and it will suck that moisture because it starts to keep the warm, the stone, solid stone, starts to keep it dry and sucks that moisture out. Because you're heating the place as it should be heated. If you're using convection heating, what you're doing is you got that cold air, cold walls, cold everything else. You're just bouncing that cold air, and you're trying to use the hot air to bounce off of that cold air. If you're heating the area directly, you suck that coldness out, so it dries out the blocks, the bricks, the fabric of the building, and sucks that moisture out. I have an example of that. We did a church hall in Sevenoaks in Kent. They had parquet floors, and the hall was never really heated properly, so there was lots of moisture. And they put in the infrared heating, and after a month, with sporadic use, what happened? The parquet floor started to shrink because there was damp and moisture underneath the parquet floor, which the infrared was now sucking out. So, and also the moisture in the wood started to shrink the floor in a little bit. So they did have to go and do some remedial work because historically the building was not heated as it should. So I hope that answers your question, Nick.
Okay, thank you.
Damian, I have a question.
Sure.
You mentioned earlier, I think, correct me if I'm wrong, that a well-insulated building would require something in the region of 140 watts per square meter to be comfortable.
Yeah.
Okay, so we are working with Reach Village Hall.
Mm-hmm.
It has a main hall area of around about 110 square meters.
Mm-hmm.
So if it was 140 watts per square meter, that would equate to about 14 kilowatts,
Mm-hmm.
which the price we pay for electricity equates to about £5 an hour.
Mm-hmm.
How does the running cost generally compare with? We currently have oil-fired boiler providing the heat. How would the two compare?
So you have to go back to the different types of heating. So you have the convection versus direct heating, first of all. But secondly, I wouldn't say carte blanche that 140 or 150 or 130 watts or 110 watts per square meter is appropriate for any hall. Before I make that assessment, I need to make sure that I have the particulars of that hall, because your hall might call for more than 140 watts per square meter or less. It just depends on the U values, usage, and also positioning and the type of building it is. So if you have oil, generally oil and gas would be a little more cheaper than running electric heating, any type of electric heating. However, if the building is warmed to a degree that you want it to be warmed at, in terms of your temperature, in terms of your frequency of use, you will get up to temperature quite quicker with infrared heating solutions, because you're heating the objects in the building and the fabric directly, meaning you're getting up to temperature quicker, or you feel comfortable quicker than you're using any form of heating other than that. And the length of time you would take to stay on should be less than what you're using presently. So if we've done it correctly, and if we've done the U values and we've designed the system for that hall, not just a typical, here's 10 heaters, go and put them in. If we design it correctly, we'll be looking at probably about half an hour thereabouts to get that hall up to temperature, and afterwards it will just tick over, and then it will drop off. So I can give you an example of Kim Bolton Village Hall, because I know that's the one that's been installed in 2015 now, and how they operated. Half an hour before the event, they turn it on. If the event is a 3-hour event, it gets up to temperature within an hour, and they turn it off. And what they have done since we've installed it, they've installed solar panels, and they've also installed battery storage. So their energy bill went from, I think, this is a few years now, they went from 4,000 or 5,000 per year down to 400 to 500 pounds. But that's doing all the measures that they have put in place. So I hope that answers your question. I know it's a long-winded answer, but it really depends on the hall that we're dealing with.
Okay, another question related to the power consumption.
Yep.
Is it necessary often for large buildings to modify the electrical control panel?
Yes, sometimes.
We only have 60 amp main fuse.
Yeah, you might have a 60 amp main fuse. Yeah, sometimes we walk away because it's cost prohibitive to do anything. Sometimes we do that. So in our fact-finding mission, we ask for the building fabric and how the building is used. We also ask for electrical, your condition report, and also some pictures of your distribution board. And if we work out quite quickly that it can't be done, we tell you a few things. We said, And I've done this with a church hall in North Suffolk. Suffolk. So what we've done, they only had an 80 amp supply. We needed 60 amps of heating, and what we did is we put in a power regulator. So, and what that means basically is a diverter. If the power is needed for turn the kettle on or turn different things on, the power will go to that, and the heating would come off for that period, and then it would come back. So it is limited, but we have done that in the past. But it really depends on the building itself. Next question, or next answer on that is tell you that you need a upgrade. It's quite easy to go from a 60 amp to, let's say, a 100 amp supply, change the fuse head most of the time. But and that sometimes is negligible cost or no cost at all. But I've had in the past where, and I'm dealing with a church at the moment where the UK Power Network has said to them it'll cost them £15,000 to upgrade to a 3-phase supply. Now, that puts the entire project a step back, because you're looking at 15,000, the heating might come up at 10,000, the installation might come out another 5,000. You're looking at a £35,000 project, whereas they were thinking, I'll just get some heaters and put it in. So we on that basis, we haven't done any work on that particular project or design that project yet, because it's not viable at this stage. And if they come back to us and say we can do it because we have the funds, then great, we will do that. Hope that helps. Martin did have his hand up, but I'm not seeing him at the moment.
Yeah, I thought perhaps I wouldn't ask, but I think it might help. Big difference between a kilowatt and a kilowatt hour. A kilowatt doesn't cost you anything.
Yeah.
So your proposal level, you come up with a loss calculation depending on the hall, I guess, and from that you derive a peak kilowatt requirement that will maintain the hall at reasonable temperatures and consume so many kilowatt hours, which is what we pay for. Is that correct?
That's correct. Spot on.
Thank you.
Okay. Okay. So you can still see my slides, hopefully. And I got into Q&A, and this is this is a little video.
Hello. I just wanted to know if it upset Wi-Fi at all and that sort of thing.
No. So you need Wi-Fi in the hall if you have. If you don't have Wi-Fi, we suggest a 4G Wi-Fi router, which it's available on Amazon. 4G router is about £70 thereabouts, and a SIM card, which is a plug-in SIM card into the Wi-Fi router, would cost you whatever you pay on a data package. So we've had some halls that have installed it, and they pay £10 a month or less, depending on how they use their data. And we put all that together and run it as an app itself. So no, if you do have a router, we would need a port to plug in, an Ethernet port to plug into the router, and also plug the hub into your normal socket. Does that help?
Yeah. Okay. Thank you.
Okay. Here is a little video of a hall. This is not a hall. This is actually a dance studio. It's in Chelmsford, and it's called Young Generation Dance Studio, and they do all sorts. So I'll just show you this video. And one last one. This is, get it to play. This is our church that we did in Chesham.
Don't know if that one might have. Oh, it's just started moving again. It's paused for me.
Oh, sorry.
That's okay.
All right. So yeah, that's it. What you may have seen on a couple of those videos is different thermostats. So you young gens, you saw a thermostat that has 3 pins and it didn't have a lockbox. So that was back, I think we did that back in 2018, and we didn't have we weren't selling lockboxes there. And then the church itself, you saw a kind of rectangle thermostat. That thermostat is not connected to any internet. That's just a standalone thermostat. And that customer goes in and turns the thermostat on for congregation, maybe 2 hours, and then at a set temperature, and then heaters goes off. So I think that is it. Any other questions? No,
No,
good.
doesn't look like it.
This is good. This is good.
I wonder if just as a bit of a summary, if you could just give us an idea of kind of 2 or 3 things which would make a hall or a building suitable for or well suited to infrared heating.
So I'll come back to what Paul suggested, or Patrick. Should we take Patrick first, or?
Sure,
yes, please.
Yeah.
Just a very quickie. Going back to Hallmaster and your discussions with them, when do you expect these to finish?
Latter part of this year. I can't say. It's not imminent. Let's put it that way. And it's not only Hallmaster, but any API we can plug into at this stage. But we are still in the early stages of developing everything that we need to do for that. But watch this space. It's coming.
Okay, will do. And just one last thing. Since we've got the system in, if anybody wants to come and have a look at our hall and see it in situ, you're more than welcome to.
Oh, thanks for that, Patrick.
It's the Offord Village Hall. We're between Huntingdon and St. Neots, if anybody's interested.
Thank you very much for that, Patrick. Appreciate it.
No problem.
Thank you. Patrick, are you happy for me to share your email address when we send out the slides?
Yeah, no problem.
Okay, perfect. Thank you.
Okay, I think we have one in the chat again. Is there anything in the chat? Other than, okay, that was Nick. Okay. So coming back to your question, Ollie, there isn't any typical hall that infrared heating would not work in. And the reason I say that is if the hall is poorly insulated, we would need to put in more kilowatts. If it's very well insulated, we need to put in less kilowatts. So, and I'm just going to give you an example. We had a hall that came back with a design, and they told us all the U values, architect's design, and what they're going to put in different areas. And based on our calculation, we would say this hall needed 40 watts per square meter. based on the information that we receive. Now, 40 watts per square meter is extremely low. It's almost like a passive house or passive building you want to put in. And we scratched our head and says, you know what? Just to be on the safe side, let's take it up to 60 watts per square meter, which means that we needed 4 heaters instead of 2 heaters. And that the cost of those heaters the cost of that product is incredibly low compared to a building of that size, which is poorly insulated. So a poorly insulated building would be, we may be looking at 140 watts per square meter, 150 watts per square meter, depending on the building. But this one, we come in all the way down to 40. So in conclusion, it doesn't really matter the building that we're heating. It matters the value of that building, the U value, the usage, and in how you want to use the system itself. If there is only one day a week the system is going to be used, and you want it to be heated within 10 minutes, then we need to put in more power. If it's regularly used on a daily basis and it's consistently used and is well maintained, we put in less power. And because infrared heating is so good at retention, because remember, if you have the heat dissipating into the walls, into the fabric of the building, it retains it. Especially if you've got an old village hall or an old building that has solid stone walls, and we've got that up to temperature, it will retain that temperature if it's in constant use. So if we're saying that a hall takes 30 minutes to get to temperature, which is a well-insulated hall, poorly insulated hall with regular use, it might come down to 15 minutes or 10 minutes, just depending on how that building is used. And because you can control everything via an app, you have that visibility. So some halls, there's a Willingham, I don't know if anybody knows Willingham Parish Council. There's a building, a large building, and we've heated that entire space with our heaters in the main hall and all the auxiliary rooms. They turn it on in the dead of winter. They have a preheat solution. So at 6 o'clock, they turn it on to get it up to 12 degrees. And that takes about 20 or 25 minutes to get up to 12 degrees at 0 or minus in that application. So it's much easier for them to go from 12 to 19 than it is to go from 0 to 19. And it's much quicker. But in their office, it's 5 minutes for them to get up to temperature in their office in the dead of winter. And we haven't installed more than 80 or 90 watts per square meter in that office. So it doesn't really matter. We can heat any building, providing we've got the information of that building. Does that help?
I think it does. Yeah, I think it's good to know that it's more the solution than the building itself, by sounds of it.
Yeah.
Perfect. Okay. If there's no other questions, we'll end there. Apologies that we've overrun by a few minutes. But yeah, thank you, Damian, for your time, and thank you everyone else for coming along. I hope you found that useful, and we'll send out the slides after this as well.
Yep. Patrick wants to say one thing. Yes, Patrick. Oh, thanks, Patrick. Thank you, Patrick. Take care.
All right. Thank you all.
Pleasure to meet you all. Take care. Have a good day. Thanks again.
Bye-bye.
Ta-ta.
Okay.